Hello, everybody. So I'm Amilcar Lucas. I'm based in Germany, and I've been contributing to the ArduPilot project since 2011. In the last 18 months, I started a new little project called ArduPilot methodic configurator. So on this talk, I will first focus why that software exists. What does it do? How does it do it? Is it reliable? Is it compliant? And how to use it. In the end, there will be a small demo. So, why does it exist in the first place? So ArduPilot is very flexible, as you all know, and it supports right now 266 different ArduPilot boards. So I'm not talking about AP per if. AP per if, then it goes up to 300, but ArduPilot boards alone, 266. Hundreds of different sensors and all the flexibility that we all know it has. So in order to work properly, of course, all of these parameters need to be correctly configured and tuned. So the flexibility is there, but you have to know how to use it. And I've read over, I think, 128,000 posts on the forum in the past few years that I've been active. And I see a recurrent theme from our users asking, okay, how do I configure that? And should I configure this before configuring the other one? And what's the sequence and all that stuff? And it comes because we do have extensive documentation. There's over 1,600 unique pages. I know I wrote an engine to crawl them all, and there are 1,600 unique pages on our wiki. So it requires users to learn a lot and use different tools, and they lose their way once they start reading the wiki. They veer off to one direction, then to another direction. There's no start to finish. So in the end, what happens is a lot of users end up incorrectly configuring their vehicles and coming to the forums and complaining about it, and some of them just don't come to the forums, just go to other firmwares and other stuff. So that's why the configurator got created, to try to address exactly these pain points. So here are some other problems that the configurator addresses. Missed mandatory configuration steps. There are steps that you need to do, and people just ignore those because they're overwhelmed or they want to get their vehicles just flying as fast as possible. Then they do weird stuff like auto-tune before notch filter and mat fit before the current sensor is calibrated, and then they go on and calibrate the current sensor, but now the mag fit doesn't work. Yeah, all kinds of those things. Then we have weird stuff that's been historically there. So if you're trying to configure an ESC, well, there are parameters to configure the ESC under the prefix ESC, under the prefix serial. Some of them are under the prefix mod. Some of them are under the prefix servo, and others from the prefix can. So you're trying to configure an ESC, but you have to look at all these other prefixes. So a parameter tree, parameter name tree, it's not going to get you there, because you do look at all the parameters starting with something, but you have to change parameters all over the place. So, and when you're doing a configuration step, sometimes if you're using a tool like GCS, it does present you the parameters, but it doesn't present you the documentation on how to do the ESC configuration, or what is the specific documentation for your flight controller, because we support 266, care about those. They care about the ones that they have connected right now. So there's some stuff in there that could be improved. And when you're reviewing a configuration or when you're doing a configuration, there's no way on current ECSs in current ways to write down why you're changing that parameter. Okay, today I'm changing the parameter because I did a flight test and I got that and that result. So that a couple of months later, when I go back to it, I get to see why I did that change. So here's a comparison between generic ECSs. So I have placed in there mission planner, queue ground control, but pretty much any other DCS will behave like that, mission proxy, MAF proxy and stuff in the configurator. So the first point is extremely important. It's probably the most important point of all of them, okay? Full automatic configuration. Can you do a one button push configure of a vehicle like ArduPilot? No, you cannot do it, not with Mission Planner and not with a configurator. So the configurator is not a solution. You press a button, it's done. That's not the point, okay? But it does have other things, like it allows you to do a semi-automated configuration because it's a wizard-like interface, and you have to do step 1 before you can do step 2, and you have to do step 2 before you can do the step 3. So it guides you to that configuration step. Explains you what to do, explains you when to do something, because there's a specific order. You cannot do specific steps before you do other ones and other ways around. So you have to do it in a specific way. The documentation, the same thing. So the parameter documentation, if I'm looking for, I'm doing a motor calibration for it, or a motor test on Mission Planner, then I don't have a way to see exactly what motor spin mean is, because the documentation for motor spin mean is actually in the full parameter list, and that's another screen. So the whole thing is not available in a single place, all the information in a single place. Document why you change each parameter. It's something that you also want to do, and it does automatically install Lua scripts. So users struggle sometimes to put a Lua script on a flight controller, and this one just says, okay, and now it's time to do MagFit. Do you want to place the figure 8 script on the flight controller? And you just say yes, it downloads the flight script from the internet, uploads it to the flight controller, that's it. You only pressed one button, you get all these operations automated. The other thing is, every time you configure flight controller to the configurator, it downloads the entire parameter sets and does a backup on your file system. So you always have a backup before you use the configurator, because that's the very first thing that the configurator does. And every single time that you plug a flight controller and you start the software, the configurator creates a new backup file for you. So how does it do its job? It's a wizard-like interface. It starts by checking for software updates. If there's a new software version, you're asked if you want to update. Then it connects to the flight controller. Then asks you to create a new project or open an existing one if you already have one. Then you define the components that your vehicle has, and then you do the parameters. We'll take a look at this later in more detail. So the parameter configuration steps, there's different categories and different things that you can do. So in green, the first one is optional. So you can skip that if you don't need that. But it has to be done in the very first place, because you need to put the FC in the freezer. And if you have assembled your FC onto your vehicle, now you have to put the entire vehicle in the freezer. That's not very feasible. So you should do that before you even put the FC on your vehicle. So that's why it's on the very top, and that's the very first thing. Then you need to assemble all components except the propellers. It's obvious. And then there's the basic mandatory configuration. You have to configure every single device driver. You cannot tune an unconfigured vehicle. There's many users, beginners, that try to do that. They try to go to auto-tune before even configuring their GPS. Don't look at me like that. It happens. So then you have the minimalistic mandatory tuning that you have to do. But after that you can fly. It's enough for a lot of users. And the software allows you to jump and skip all the other steps, because these are also optionals, and go directly to the last step, everyday use, where you disable logging and do a couple of other things. And that's it. So basically, for beginners and users that don't need a maximum performance, you just follow the steps, jump to the end, you're done. Now, if you want a little bit more performance, do one of these. If you want a little bit more, do a next one. So the idea is that the more steps you do, the more performance you get. But the first steps give you the more bang for the buck. How are the configuration steps structured? So there's two kinds of configuration steps. Simple ones that don't require experimental data gathering. They're just one configuration step. You configure your GPS and you're done. That's an example. And there are others that require experimental data gathering. So they're divided at least in two steps. The first step, you set up the experiment. You configure the parameters that are required to gather the data and perform the experiment. Then you go and fly. And after you've flown, after you've done something like a web filter tool, you come back and you feed it back to the tool, and the tool reads the data from the flight controller again and continues. So it's basically divided into multiple steps when you have to do an experiment. So one of the advantages of the software is that in a single view, so the user can see the parameter default values. He gets access to the tuning guide, so a document explaining which step to do, and it's linear from top to bottom. The parameter documentation used by the firmware version that they have on their FC, not the latest one, but the one that they have on their FC. The parameter limits, so the mean and max recommended limits, the current flight controller parameter values on the flight controller, the connections, so they get to see if their GPS is connected to GPS 1 or GPS 2 and all that stuff. The vehicle component specifications, how big are the props? So there are some components that are very important for the configuration and tuning, and that is also there. The wiki documentation, so links to the relevant page for the wiki documentation. So if I'm doing a notch filter, I get a link to the notch filter page. If I'm doing something else, I get a link to something else. So they get to see the documentation. It's there and it's good, but they get to see it step by step, and they only see the documentation that's relevant for the step that they are currently at. So they don't need to go and read 1,600 pages. So they need to only read those that are presented to them. And if they are required to use a web tool, then that web tool gets opened automatically in the background for them. So it pops up a browser window with the excellent web tools that we have, if that's relevant for this step. So if they're doing the notch filter calibration, then they are first required to set up the notch filter, go perform the flight, and after performing the flight, the web tool opens automatically in their Firefox or Chrome or whatever, and they don't need to go and look up where is the web tool. They don't need to go and look up the URL for that. So is it reliable? Well, it has been used in a lot of vehicles. We have been growing our user base in the last 18 months, and we have used it on vehicles from 600 grams to 350 kilos. All of them use the same sequence. So that same sequence of steps can be adapted to all of these things, and it does work. So it's meant for beginners to advanced users, all of them, same sequence, big and small vehicles. It has currently 1,644 regression tests, and currently almost no known bugs. So is it compliant? So how is the software built? Well, the user interface, it's a little bit old because it's TK Inter and it's not the newest and shiniest, but it uses the paradigm, what you see is what gets changed. So if I have 5 parameters on that list, the tool will only change those 5 parameters. The tool will not go behind your back and change some other parameter. It only changes the little parameters that are relevant for that step. That's one thing. It has been translated into 5 different languages: German, Italian, Chinese, Japanese, and Portuguese. It has no menus, visible or hidden, no menus whatsoever. From the code quality perspective, PEP 8 follows PEP 8 coding style guides, PEP 484 type hints, and all that annoying, boring stuff. It has logging with 5 different logging levels, so from debug to info, critical, fatal, and all that stuff. Follows semantic versioning, and the change log is also, the commits are all following that semantic versioning thing that allows you to classify what kinds of commits are there, so you can see clearly what are the bug fixes, what are not. It's linted with 4 different linters, so PyLint, MyPy, rough, and PyWrite. It has pre-commit hooks, CI/CD. It has 30 different CI/CD workflows. It has 6 automated robots doing commits and merge requests, like Renovate and Dependabot and that stuff. Now, for the audience on this room, this is probably the most important slide. So how is it built? What's in the background? Well, AMC, it's just a Python engine, okay? But what it's doing is reading all the information that it needs from JSON files. So there's a JSON file to explain the components on your vehicle. There's a JSON file to explain how these components are grouped in a vehicle. There are JSON files to define the configuration steps that you want. So currently there's an ArduCopter.json, and that's the one that I maintain, and that's the one that works. And then there's the ArduPlane.json that currently it's just a copy of the other one. I'm waiting for somebody, I hope on this room, to help a bit and try to bring that ArduPlane.json into chip and get those steps, those configuration steps to from start to finish to configure a plane properly. The same thing for other vehicles. And then, parallel to the JSON files, you can have an MD file. That's basically the documentation. So, and there's links between those. So the MD file has links to the JSON, and the JSON has links to the MD. So by providing those things, we can add support for newer vehicles like sub or heli or whatever. And even if somebody really, really wants and gives a JSON file for a PX4, this thing could configure PX4 because it's basically just talking Mavlink and MavFTP, and that's it. So you don't need to know Python to change the software or adapt the software. If you want to add a configuration step, you just need to do a little change in the JSON file and do a little change in the MD file for the documentation. So this is about the customization. Customization without changing the source code, because everything is data-driven on those JSON files. the vehicle components, the components themselves, and the configuration sequence. All of these things, they have a JSON file and a schema for the JSON. So if you want to validate the data, the software validates that with the schema, but you get to see also the schema for the JSON file. Now, the roadmap, what's planned in the future? So in the near future, we plan to do this little addition because currently it's the biggest pain point of our users to get the ESCs correctly configured. And sometimes they need to change the frame type. So instead of telling them, okay, you need to read the documentation and find out what's your frame type, they get a nice little picture of it, courtesy of Yuri. And they can use the drop down there to select what's their frame type. They also get warnings if the voltage is not correct. So if they try to spin up the motors without a battery, the software will tell them, sorry, you have to put voltage on this thing, otherwise the motors will not turn. And they can run the motors. Once they run the motors, they tell which orders the motors are, and then the software goes in behind and sets the correct servo functions for the, okay? So that's one thing in motor tests. Then there's status messages. Currently, we don't show status messages anywhere. Automate downloads of the last log bin file. That's very useful because right now to download a bin file, what I do is I use mavftp and log into the board, list all the files, and get the last file. So instead of doing that, I'll have a button that does that for me, automates that, goes there, gets the last file, puts it on your hard disk, so you can use any analysis tool for that without leaving the tool. Simplify and automate the S configuration we have with BD-Shot is a hairy monster, so you have to set the masks right, you have to set all kinds of weird things, and most people don't get that right, but I'm pretty sure that we can do that with a lot less parameters and in a more user-friendly way. So, and lots of people ask me to make it closer to Betaflight, make it as easy to use as the Betaflight configurator. Well, that's hard to do on a software as complex as ArduPilot, but that's something that I will try to do. I'll try to make it easier and easier for the users to use this and to get their vehicles running. But it's going to take a while. And I hope that some of you get inspired to help me out on this journey because it's hard to get all the vehicles right. And I'm focusing only on Copter because that's the ones that I have, that's the ones that I use, and I really need the help on the other ones. And last, automate, and then automate some more. So I'm a big fan of automation, and if it's automatable, I prefer to do it automated than to tell the users, okay, click there, then go there, then do the other stuff. So this thing has a configuration guide, has a user manual, has use cases. So for different use cases, documented how to use the software, where to click, and all that stuff. The software architecture is also documented. There's a YouTube channel with a couple of videos. I'll add some more in the future, but there's some of them. And there's an ArduPilot trained AI chatbot that we've trained with the entire contents of the wiki. So the 1,600 pages of the wiki, they have been indexed by this AI chatbot. And then the configuration guide, the user manual, and whatever, all the documentation from the ArduPilot methodic configurator have also been thrown in there. I also thrown in there the documentation from QPilot, their entire documentation base. I think CUAV on Olibro also got indexed. So, and all the YouTube videos on ArduPilot channel, the ones that have subtitles are also indexed in that chatbot. So you can take a look at it Now, so that you get an idea. So this is the, sorry. No, I cannot do that. Not that easy. But if you go to the website of the methodic configurator, there's a little icon on the bottom right side, and that's the AI chatbot that you can click, can ask questions. It has all this documentation, and we'll try to answer them for you. So, it's my firm belief that this will reduce the human error probability while configuring a vehicle, increases the configuration speed. You don't need to switch tools and click a lot of buttons. Increases the consistency and the reproducibility. You can have multiple vehicles and it's like a checklist. So if you have to do 10 vehicles, you have the checklist to go for all those 10 vehicles. And it has documentation and traceability because for every single parameter, you can add that information in there. So now let's switch to the, how much time do I have? 5 minutes? All right. So let's try to do a quick demo. Somebody happens to know the shortcut to mirror the screen? Yes, it's Windows. All right, cool. Windows print screen? Okay. No. It's really weird now. Mm-hmm. Thank you. That was it. So when you start the configurator, it allows you to define the vehicle components of your vehicle. And this is the interface for the beginners. So you can define where you have connected your receiver and what protocol it uses, then where you have connected your telemetry and what protocol it uses. Same thing for battery monitor. Then you configure your battery voltages and number of cells, capacity. For DSC, again, you configure what kind of connection it has in the protocol. And for the motors, you tell them the number of poles. For the propellers, you tell them the diameter inches. And then for the receiver, again, the connection, how it is connected to your FC. And once you've done all that, you just can save data and start the configuration. But I will now switch to the normal mode that has a little bit more details and show you how you can compose the vehicle. So if you happen to have some frame, okay, I have some frames here already predefined. You can enter all the data for a frame, and once you've entered all the data for that frame here, manufacturer, model, and all that stuff, you can just click the plus button, and it will save that as a template so that later on you get that same data by just clicking here. And you can select for the RC controller, select which RC controller you have from a list. You can do the same thing for a transmitter, receiver. So every single one has these templates, and that saves you time if you're creating vehicles. Okay, and once you've done that, you can go to the next step, and that's the GUI for it. So on the very top, there's a bar where you can see where you are in the configuration process. Some of these things are painted in black. Those are mandatory things. If they're grayed out, they're optional, so you can skip them. As you can see, there's lots of steps here that are optional. Then there's the documentation for every single step. So right now we are on step number 5. And you get to see the documentation for that particular step. You also get to see on mouse over why you're doing this step and why you're doing it right now, why you're not doing before and why you're not doing late. Why is the remote controller done in step number 5 and not on step number 50? Okay, basically. It also tells you if it's mandatory or not, and it will automatically open the documentation in browser if you click this button here. So the first time it connects, and it detected that it has a Q+, so it will open on the browser, it will open the documentation for the Q+. Then for every single parameter, you get to see if they have their default value or not a normal value. So if something has a default value, it will be marked in light blue. If you change that from a default value to something else, then it's marked in white. And then there's that little symbol between those two things that tell you, okay, if I upload this parameter to the flight controller, then I will change the parameter on the flight controller. And then the main part of it all is this field here. That's the reason why you change this. So in this case, the arming rudder, usually we disable that. We prefer on our drones to use the switch. So I will say here, because we prefer to use the switch. Okay, and that gets documented so that a future worker, co-worker, or me in 12 months remembers why is that parameter being set to that particular value and not something else. Okay. So, and once all that is done, I can just upload the selected parameters, and it will save this small parameter file into the hard drive, and it will upload everything to the cube. Then it will download everything from the cube, because we have a problem on our parameter protocol, Mavlink parameter protocol. Acts are basically ignored. Sometimes you set a parameter, it does not get set correctly. So, and there's no way of finding out that the parameter has not been correctly set. So we download everything, then we upload everything, we check if they're okay or not. And if they're not okay, we'll upload again. So that saves trouble for a lot of users that sometimes think they've set the parameter, but they haven't, because something went wrong, and the GCSs don't tell them that it's gone wrong, because there's no way of doing that, because there's a fault in the Mavlink protocol. I already talked to Peter Barker about that, by the way, and we'll maybe try to fix that. Let's see. So once all that is done, it then switches to the next step and presents you the documentation of the next step. And the documentation for the next step is to configure the telemetry. So my job right now is to read this documentation. It also opened some other documentation here on our wiki, opened the documentation for the telemetry landing page. My job again is to read this documentation, and that's it. So now that I've read the documentation, I should be able to set these 4 parameters. So, and that's what we're trying to ask our users here to do. It's not like, look, you have 1,200 parameters, set them all. What I'm telling the users to do is, right now, concentrate on the telemetry And once that is done, once you read the documentation for the parameter, for the telemetry parameters and set them, you're done. You can go to the next parameter, but you don't need to read the entire documentation. All right, that's it. Thank you very much.
Thank you for joining us for the ArduPilot Developers Conference 2025. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, QPilot, High-Tech, Polybro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus. Organised by KH Unmanned. Hosted by 3DXR in North Yorkshire. Broadcast by Q Branch.